Okay, in this video, we're going to work through one of our practice problems of graphing a parabola when given the quadratic form. It's written in standard form. And what it wanted us to do was have 5 points plotted on the graph and make sure that out of those 5 we have our roots and our vertex plotted as well. And then some of these problems will ask you to find what's the vertex or what's the equation of the axis of symmetry or some other things. But we'll go through the process of how to get the points to graph. And so when given it written in standard form, this equation here, something we can try to do is we look at what it requires us to have, and it requires us to have our roots. All right, so remember that roots themselves are basically X-intercepts when it comes to graphing. They're the zeros. Now, we're going to be looking for real numbers, and I'm getting more along the lines into maybe some algebra 2 where I could have some roots or zeros that are not real. But for our class, we're focusing on our roots being our X-intercepts. So to find our X-intercepts, we're going to put in 0 for y, and we're going to go solve for x. And so I can factor that. I can pull a negative out. That makes x squared plus 8x plus 7. And I continue on. That's going to be negative 1 times. That'll be x plus 1 times x plus 7. And I solve that, and I get x equals negative 1 and x equals negative 7. And so our x-intercepts are at the coordinates negative 1, 0, and negative 7, 0. So I have 2 of my points that I need. So I have negative 7 and I have negative 1. Now, what I would do from here is I would next go find my axis of symmetry. And we'll see why here in just a second. So my axis of symmetry, remember that that's going to be x equals negative b over 2a. And so I plug in with that, and so that's going to give me negative 1 times negative 8 divided by 2 times negative 1. And we're going to get an axis of symmetry here of 8 divided by negative 2, which would be negative 4. All right, so my axis of symmetry, I'm actually going to graph this. Now, we don't graph this on this exercise here. This is from Delta Math. But if I go graph my axis of symmetry, so I'm just going to make a dashed vertical line here, because this is going to help me plot some points. So this is my axis of symmetry. Now, I know that my vertex has to fall somewhere on that axis of symmetry, and the vertex was one of the things we were required to graph here. So let's go through and we'll find our vertex. So to find our vertex, we take our axis of symmetry, we put that x value in for all the x's. And then we evaluate. So we do that, and we're going to get y equals, that'd be negative 16 plus 32 minus 7. And we know that we have the x value of negative 4, and then we evaluate that, and we'll get our y value of, let's see, negative 16 plus 32, that makes 16. 16 minus 7 makes 9. So I'm going to have a vertex at negative 4, 9. So there's my vertex right there. Now, they require us to get 2 more points. And so what we can do from here is we have a number of options. We could find our y-intercept, or we could just pick another value to substitute in for x, and then we can get 2 more points. But if possible, I'm going to say let's go find the y-intercept here. So y-intercept. So y-intercept, you make x equals 0 and you evaluate for y. So we got y equals negative 0 squared minus 8 times 0 minus 7. And the y value of the y-intercept is negative 7. So 0, negative 7 is my y-intercept. So I put that point there. at 0, -7. Now, here's the thing about the axis of symmetry, is remember the axis of symmetry has to split the parabola right down the middle. So if I have this point at 0, -7 that lies 4 units to the right of the axis of symmetry, there has to be the same point has to exist 4 units to the left of it, so that way it will maintain its symmetry about that point. So that point right there that I'm putting a little X through is a point that I could evaluate and get for this parabola without actually having to manually compute to get the Y values. And then once you plot the points, it would sketch the parabola that would pass through those points, where it would continue to go down and pass through all those points here, and it would plot the graph. And so by hand, that's how we would graph it. Now, if I wanted to use some technology to help me come up with some points, because some of these can get a little crazy in terms of the Y values they want us to get, because the equation will have some decimals in it or something else. And if we don't have a calculator, here's an option. So I could type in this equation in Desmos, and I could graph it, and I could look at it and see. And the thing about Desmos is it will go ahead and give you the key components, so my intercepts, my vertex, but it won't give you any other points to plot unless I get a little creative. So what I can do is I can click inside Desmos, click the gear button, and I can copy this equation a second time. So that way it'll make the identical equation below it, and then click the table button, and it will make a table of values. And so I get numbers that I can use to plot points that fall on this curve. Now, on this grid, it goes from -10 to +10, both along the X and along the Y. So if I needed more points, what I could do is I could hand type in X values and see what they would get. So like -8, and I would type it in and say, oh, it's at -7. And I could continue that on to build my table to get the points to graph as needed. So that's how we graph these quadratic expressions, and we use our ability to find the X-intercepts, the Y-intercepts, and our vertex, along with the axis of symmetry to help us graph it when doing it by hand.